Hello friends, in this video we're going to solve 2021 paper C7 BSc 3rd Sem Physics of Dibrugarh University. So this is part 1, okay, and we have already solved 2020 paper, right? So we have already solved. Links will be provided in the description box, and please subscribe the channel if you are new to my channel. Also share with your friends, okay, inspire me to create new contents for you. Now let's start. So this is the correct option here. So here the correct option is this. First one is the correct option here. So now let me go to the next question. So here is the next question. So we have to convert this one to the binary 52.875. so how to convert this one to binary? So 52, let's divide it by 2, okay, then 26 remainder 0, then 13 again remainder 0, then again 6 remainder 2 3 is 6 remainder 0, 2 1 is 2, then here it's gonna be remainder 1, right? So that's what we're gonna have. So when you convert 52 into this binary, then 110100, that's what you will have, right? That is your answer. Then 0.875, how to convert this part? First multiply it by 2, then you're gonna have 1.75, right? So which can be written as 1 plus 0.75. Then again multiply 0.75 by 2, then you're gonna have 1.5, that can be written as 1 plus 0.5. then multiply 0.5 by 2, then you're gonna have 1 is nothing but 1 plus 0, right? So here you see 1 1 1, that's what we have got. So 52.875 will be equal to, so 52 is this 110100, then point, this part is 111, right? So the correct option is this. So hope you have understood. Now let's go to the next question, question number C, okay, maximum with missing the maximum which is missing in this expression, in this given expression. Let's find out. Now which option of this one will be correct? C, question number C. Here you see this is the expression given, okay. Now A can be written as you see A can be written as A plus B bar into A plus B, right? This is equal to nothing but A. So we can write, instead of A, we can write A plus B into A plus B bar. Then we can write B bar plus A as A plus B bar. And similarly, we can write B as A plus B into A bar plus B, that is B. So A plus B into A bar plus B, right? So where we have bar, A bar and B bar, these are replaced by 1, and A and B are replaced by 0, right? So first 0 0, then 0 1, then 1 0 1 again 1 1, not 1 1, 0 0, then again 1 0, right? So A B replaced by 0 0, then 0 1 0 1 0 0 0, sorry, this is 1 0, right? So this is nothing but 0 in decimal, this is 1 in decimal, this is 1 in decimal, this is again 0 in decimal, this is again this is 2 in decimal, 1 0 is 2 in decimal, right? So now this is your M0, this is your M1, this is your M1, this is your M0, this is your M2. So M3 is missing. This is the correct option. So hope you have understood this. Now let's move on to this question. Question number D, 1D. Now you see what is this here, which of the following is not correct? So this symbol represents XOR, right? XOR. So now you see what is the truth table of XOR. This is your XOR, right? A and this is B. So truth table, or if you observe the truth table of XOR, so this is Y suppose, then you will observe that, wait, when inputs are different, then it gives 1. So here you see in this options, so last option was removed from here. There was one more option, that is number 4, that was A XOR A bar is equal to 0, right? So if you observe the truth table of XOR, then you can see when the observations are inputs are different, then output is 1, right? So here you see, so here you have A and A bar, that means that it is obvious that inputs are different. If this is 1, that must be 0. If this is 0, that must be 1. So in that case, this result should be 1, but we are getting 0 here. So that's why this option is incorrect option. This fourth option is incorrect. So your answer is option number 4. Your answer is option number 4, right? That is your correct answer. So now let's move on to next question. So here it is, when flip-flop is reset, outputs will be, so this is the correct option. Output should be Q is equal to 0, Q bar is equal to 1. So that is the correct answer. Now let me show you the answer of question number 2. Draw the block diagram of general purpose of CRO. Mention the different parts. So let me show you the answer. So this is the answer to question number 2, right? So this is the answer of question number 2. Now let me give you the answer of question number 3. First pause the video and note it down, okay? And this is the answer to question number 3, okay? So I didn't get enough time to solve this paper, so I have taken the notes from my students. So I have uploaded the handwritten notes. I didn't get time to make the slide properly, so that should be 1. So let me write here, this is 1 and this is 9 9 9 9 and 9, right? So that should be 2, right? So this is the answer to question number 3. Now let's move on to question number 4. Pause the video and write the answers. And if you don't have the question paper, let me show you what was the question number 3. So here you see, this is question number 3. What are the different scales of integration? Mention the number of components in each scale of integration. So this is the question. Okay, now question number 4 is this: describe how NAND gate can be used to realize XOR gate. Okay, how can we use NAND gate to realize XOR gate? Okay, so now let me explain this. Now let me answer question number 4. So here you see XOR gate. Okay, how to realize this XOR gate using NAND gate. Okay, first let me draw the XOR gate. Here you see for 2 inputs A and B. So this is suppose XOR. This is the XOR gate. So let me write, this is XOR gate, right? XOR gate, and it's gonna give you this result can be written as this, and this is nothing but, and this can be written as, A bar B plus A B bar. because we know in XOR gate, if you observe the truth table of XOR gate, as I have already explained earlier, that when you have got different inputs, only in that case it gives 1, right? Output 1. So here you see, when you take A bar and B, so A bar and B, if you give same when you give same input 1 1 or 0 0, in that case output should be 0. So here let us say A is 1, B is also 1, same input. So in that case, so A bar will be 0, B is 1, then A is 1, B bar will be again here you can say 0. So in both cases these two are 0, so 0 plus 0 again 0. So if you give here, you see, let me cut it, if you put 0 and 0, so the complement of 0, that's going to be 1, and B is 0, then A is 0, now B complement, that's going to be 1. So in this case also we have got 0 plus 0, which is again equal to 0. Now if you use different inputs, let me take here 1, here it is 0. So if you take 1 here, then it's gonna be 0 dot B is 0, so 0, then plus, and here 1, then as we are taking B 0, then B complement must be 1, 1 dot 1, that's gonna be 1. So that's how we get this, right? So hope you have understood these things. So that's why we can write this expression, XOR get expression, as this, right? Now you see, now let me take this expression as y. Here you can see, then complement of y can be written as a complement b plus a b complement and whole complement, right? We're going to write that. So now you see, according to De Morgan's theorem, we can write that a plus b whole complement is equal to a complement dot b complement. In that case, what we can write here, if we apply that, a complement b dot a b complement, that's what we're gonna get. So using this, we have got this. Just wait. So let me write this one here. Since a plus b whole complement, a complement dot b complement, right? So we have used that one. So now what we can do here, here you see, this should be again complement, and here it should be complement. So here we have used this identity. So hope you have understood this. Now you can see, we can write a complement b. So let me, this is a complement, okay, this is a complement. Now we can write a complement b as 0 plus a complement b and whole complement. Then here you can see, similarly we can write 0 plus a complement, a b complement, then again whole complement. We can write that way. Now let me replace 0 as b dot b complement plus a complement b whole complement here, and into again let us replace this 0 by a dot a complement plus a b complement, then whole complement, right? So from here we can take b common, and from here we're going to take a common. Then doing so, what we're going to have, we're going to have b common, then b plus a, b complement plus a complement means you can write a complement plus b complement, right? Then you have whole complement, then dot, again you can take a common, then you're going to have a complement plus b complement, then whole complement. That's what you're going to have, right? So hope you have understood this. Now you see, again one more thing, remember this, that a complement sorry, a dot b whole complement is equal to a complement plus b complement. Okay, this is also a very important identity, and if you use that, you can get that b here whole complement. Here you're gonna have, instead of this, you can write that, you see, a dot b complement, right? So then dot here a dot, this can be written as a b complement, a dot b complement, then again whole complement. That's what we're gonna have, right? Now I hope you have understood this. Now from here what we're gonna do, so here you see this is y bar. Now let's find y. Here you see, just let me copy this and let me go to the next slide. We have got that y complement is equal to this. That is what we have got. So from here, if you take again complement, then what you're gonna have, complement over this, right? That's what you're gonna have. So y complement over complement means this is nothing but y. That's what we have got. Now you see, let's make the circuit diagram of this equation. Now let us take that one. Now consider this part as, here you see, this part, let us take this part first, a dot a b complement, right? Then next part is this, that is b dot a b complement, this part. So from here, in order to get this a dot a complement b, a b complement whole complement, we need a NAND gate here, right? Similarly here also, we can set this part as input. This is one input and this is another input, right? We can represent it that way, right? Sorry, this is another input, this. Similarly from here also we need a NAND gate to get this a, sorry, not a, b dot a b complement whole complement, right? Now here you see, we need, now we have got this term and this term, right? So we need this, here you see. Now what we need that this one dot this one, then whole complement. In order to get this complement, we need another NAND gate here, right? This is not completed yet. Now you see, here you can see what we can do for this part. Instead of writing separately, what we can do here, just let me modify this one to make it simple. So now here you see how to obtain this. Just wait, let me use this here. This is a input here now, and so this input is b, this input is b. Suppose, let me write this way. Now let me clear this. So we need this too, right? So a dot b complement. So from here we're gonna have a, and from here we're gonna have b, right? A and b. Then if you connect it, it's gonna be, just wait. As you can see, this part is common part, that's why. So from here we have taken a, and from here we have taken b. Then a dot b we have got here, and if you put here NAND gate, then it's gonna give you a dot b, a dot b whole complement, right? And from here you can see we can connect here this one. Let me just write B properly. This is B input and this is the input. So here you see this input is A and this input is A dot B complement, and so here output gonna be A dot A B complement whole complement, right? This part. Similarly here you see this input is B and this input is A dot B complement, so here output gonna be B dot AB complement whole complement, and now we have got these two, so this one dot this and whole complement is given by this NAND gate, right? So hope you have understood. So this is the final circuit that using which we can realize the XOR gate. This is the use of NAND gate to realize XOR gate. So hope you have understood this. So now let me clear this part. Okay, so this is the final circuit. So hope you have understood this. Now let's move on to next question. 4A answer. This is 4A answer. So pause the video and note it down. Now let's go to 4B, right? So this is a 4B answer, question number 4B answer, and hope you can see the answer clearly. So hope you can see it clearly. So this is the this is A XOR B XOR then again C XOR B, right? So this is the answer, right? Now let us solve question number 5. So here you can see we need to draw a simplest possible logic diagram of this logic diagram. Here you see so first what we have here, so this is A, right? This is A, input A, so here we're gonna get A complement because it is NOT gate, right? So and here it is NOR gate, so that's why we're gonna get A plus B complement. So here we're gonna have A plus B complement, and this is gonna be A plus B complement because it is OR gate, right? This is OR gate. So similarly from it's gonna be B complement, then here it's gonna be B plus C complement, and this is gonna be B complement plus B plus C complement, and the output here it is NAND gate. This is NAND gate, so that's why this is gonna be this one, sorry, just wait, this one into this one complement A plus B, sorry, A plus B whole complement into B plus C complement and whole complement. Okay, now let us simplify this. If we simplify this, then what you're gonna have? So now we know that A complement plus A plus B complement, it can be written as A complement dot B complement, right? Then here into B plus, so B plus C whole complement can be written as B complement dot C complement, right? Then whole complement. So here, right, since A plus B whole complement is equal to A complement dot B complement, we have used that identity of Boolean algebra, right? So now you can see that here it can be taken common, here B complement can be taken common, and doing so what we're gonna have, A complement is taken common, just wait, A complement is taken common here, 1 plus B complement, then B complement is taken common, 1 plus C complement, right? Then again whole complement, right? Now you see 1 plus anything, 1 plus anything, it may be A or A complement, or 1 plus B or B complement, or 1 plus C or C complement. So this plus sign represents OR gate. If one input is 1, doesn't matter what is the other input, that's always going to give you 1. So that's why we can replace these two by 1, right? So that's why what we're going to have, A complement dot B complement whole complement, because these two becomes 1, and it can be written as, you can see, we know that A complement dot B complement is nothing but A plus B whole complement. So that's why this part under complement can be written as, this part can be written as A plus B whole complement. Again we have here complement, so one more complement, and this gonna give you A plus B, right? So what will be the simplest possible logic diagram? So that gonna be equal to nothing but that gonna be the simplest logic diagram will be A and B will be input. Here we're gonna use this OR gate, right? So we're gonna use a OR gate here. This is OR gate, and this is the result, A plus B, right? So this is the simplest logic diagram of this question. That's how we can solve question number 5. Two questions. There are two questions. One is, or we need to solve this, how to reduce this one. So let me go to the next slide here. So here you see we're going to reduce this expression with the help of K-map. So in K-map, we know that number of squares is given by 2 to the power n. So how many variables are there? We don't the variables in this function are not given. If there are 2 variables, then there will be 4 squares, and if there are 3 variables, then 2 to the power 3, that is 8 square, right? Sorry, 8 square, yes, 8 squares. So then we're gonna have 8 squares. In that case, the K-map should be, so now you see, in case of 4 squares, we're gonna make like this K-map, and in case of 8 squares, we're gonna make the K-map in this way, K-map table, something like this. But here you see how many digits are there, 1 2 3 4 5 6. So that's why this condition for 2 variables is not sufficient here. So we're going to take the case of 2 to the power 3. That means we must have 3 variables, A, B, C. Then we can put all these values. So that's why, though the variables are not given, we're going to take 3 variables, that is A, B, C. And let me draw it properly. Sorry, just wait. And here you see this is the K-map, and table, right? K-map table. Here is the K-map table. So our variables are suppose here A and here BC. So A 0 and 1, here we have 0 0. Then what we need to take? We need to take 0 1, then 1 1, then 1 0, right? So here what we going to put here, 0 0 1 2 should be written at the end, then 3 here, and similarly 4 5 6 should be written at the end, then 7 should be written here. That's how we used to write. Now you see, in this case, so out of from 0 to 7, so there is 0. So here we're gonna write 0 1. So here we have 0 here. That's why in this block we're gonna write 1, and 1 is missing. That's why we're gonna put here 0, and 3 is there. So we're gonna put 1, and 2 is also there. So we're gonna put 1 here, then 4 is also there, so we're gonna put 1. 5 is also there, we're gonna put 1. 7 is missing, so again 0. 6 is there, so 1. So now let us group this. How to group it? You see, we can group these 2 1 with these 2 ones. We can make group of 4. So from this, what we can write that here you can see in this case. So here, if you go from top to bottom, here the a and a complement, these two varies, so that's why there is nothing common, so let's ignore this. So here in these two column, here you can see at the top b is 0, here b is 1, here c is 0, here c is again 0. So that means c is 0 means c complement, this is c complement, so c complement is the common, here 0 is the common, so c complement is the common. You can see c complement is the common, then plus. Then let me take another group. How can you group another, make another group? This is one more group. So here you can see here a is fixed, not changing, so that's why you can take a. Then here you can see common is b complement, 0. Here input of b is 0 means here b complement, so b complement is common, so a dot b complement we will get, right? Then plus, and one more group we're gonna have here. This is one another group, these 2 ones, right? So taking these 2, so here you can see the common is b here, right? And a is fixed, that is 0, so a here a is 0, that's why here a complement, then dot b, because b is 1 here, b is 1, and that is the common. Here it is c, and this is c complement, which is not common, right? So hope you have understood this. So this is the expression, final expression. Let us express this using logic gates. Here you can see what we can do. We have a, b and c, so we're gonna have 3 inputs, right? So, and we have plus here, so we're gonna use OR gates, right? So now how to draw this? First let me write a, just wait, let me adjust little bit. Okay, so a, b and c, these are the 3 inputs, right? Then so here a is connected, this is a, and then so we have a with b complement, so we're gonna have, this is b, so this is b. So let me make in order to get the complement, let us use a NOT gate, right? So this is NOT gate. So here we have a dot b complement, so that's why here we're gonna use the AND gate. This is gonna give you the a dot b complement, right? So similarly, next we have a complement dot b. So in order to get a complement, here we must have to use a NOT here, NOT gate, then b, this is b, just a b, so then just wait, and this should be given to an AND gate again, this is AND gate, and here we have positive signs here, so that's gonna be OR gate here, this is OR gate. So let me find more space here, just wait, this is a, this is b, this is c, right? So this is OR gate, this is OR gate, and this is gonna be the final expression here. And c, here it is c complement, that's why we gonna use a NOT gate here, and it's gonna be connected to this. So hope you have understood. This is the logic diagram. So now let's move on to next question. Our next question is question number 6. Draw the logic diagram of decimal to BCD encoder, explain its working. So as not enough time, so I'm not going to explain. Let me give you the answer straight away. And let me tell you one more thing. This question number 7a, this is already discussed in the when we have solved the 2020 paper, right? I have provided all the links of the videos of those solution of that paper in the description box. If you have solved that paper, then you must know these things, so I'm not going to explain that. Then we're going to explain half header, right? And one more thing, I forgot to attach one part of the answer of this question, 4b. So I have shown this one only, right? So there is another part. So this table is also repaired, and here this answer is completed. Okay, so I forgot to attach that picture. So now let's go to the question number 6. Okay, this is the answer to question number 6. Just pause the video and note it down. And as I have already told you that I have explained already about this method, two complement method of subtraction in the paper 2020. I have given the links in the description box. Okay, so I'm not going to explain this one again. So now let me give you the answer to question number 7b, right? So this is question number 7b. Here just adjust your mobile yourself. Okay, rotate it in order to write. Okay, I have placed the photo horizontally. So here you see, if you cannot recognize what is drawn here, this one, let me show you. This one is nothing but a b. This is here NAND gate, then again one more NAND gate, right, which is gonna give you a dot b complement, again one more complement, right? So that is what is written here. Now let's move on to next question. So this is the question number 8. So here is the answer. Sorry, not this one. This is the answer to question number 8. Just pause the video and note these things down. Okay, so now question number 9. So now let us solve question number 9. This one. So I think I have discussed this one in the last paper as well. So let me give you the answer too. This one is the block diagram, right? So here you can see. Now let me explain, give you the explanations here. So here this question number 9 is completed, right? So hope you can see this clearly. Now let me give you the answer to question number 10. So this is question number 10, answer to question number 10, right? So pause the video and write. And question number 11, this is question number 11. So what is the ring counter? Describe the working of 4-bit ring counter. Okay, let me give you that answer. So this is the answer to question number 11, right? So now let me give you the next question, answer to the next question, that is question number, just wait. So this is the answer to question number 11 or part. There were two questions, right? So answer to this part is this one, right? Okay, now let's move on to next question, question number 12. This is the remaining part of question number 11. Okay, so after this piece, after this piece, just you have to write these things. Okay, so now question number 12, you can say that this is question number 12a answer. So here is the question, right? So let me give you the question here. This is 12a question, this is 12b question. Pause the video and note. And this is the 12a answer, and this is the 12b answer. It starts from here, right? So just pause the video and note down. Okay, this is the remaining part of 12b. Okay, 12b was not completed here, so here that is the remaining part. So now let me give you the answer to question number 3a. This is the question of 3a. What are the various registers of 8085 microprocessor? So here is the answer. This is the 13, and pause the video and write it. And the 13b is this is the 13b question. So this is the answer to question number 13b. Okay, just rotate the mobile to adjust your screen and write the answer. Okay, so now what is the next question? You see, this one I have skipped this question. Just let me go to 14. Okay, this is the question number 14. So answer to question number 14 is, so this is the answer to question number 14. So just pause the video and note it down. So as I have made this video in very short time, so I couldn't provide you the the quality video, so sorry for that. And stay connected, and in fourth semester you're gonna have more wonderful courses on different topics, okay, which are very important in fourth semester. And those videos where I used to explain the concepts of different topics, okay, and I used to take care of the video quality, and you're gonna enjoy those videos. Okay, so just stay connected and wait for the next contents and next videos that's coming up. Okay, those are very important for your fourth sem. Okay, so basically, and I'm gonna work on different topics of mathematical physics for your fourth semester, especially for Dibrugarh University. Okay, so stay connected. See you in the next video. Thank you.